So we're still talking about electric circuits, and I thought that it was a good idea to actually do a calculation where we have a combination of parallel as well as series resistors in one circuit diagram. So this is lesson 28. Let me just remove this. So we're given a circuit diagram such as this one here. So they're saying that the total external the total potential difference supplied by the battery is 12 volts. And now if we have to follow the direction of the conventional current, it would be from the positive to the negative. So this current will flow through, the total current will actually flow through A1, through our ammeter, as well as this resistor R1, right? Remember, current cannot flow through a voltmeter, so it would go through there, and then IT here will actually now split into two. So to split as the current in this branch, let's call that I2, as well as the current in this branch, let's call it I3. So this ammeter will actually measure the current that passes through this resistance as well, and then this ammeter will measure the current that passes through this resistor here, and then finally we will have our IT. So they would come there, up there, and then here I2 and I2 as well as I3 will combine again into IT. I hope that is making sense. It splits on the side because these resistors now are connected in parallel, and then there at the node they will kind of come together to now form IT, which will also flow through our entire circuit. Hoping that is making sense. Okay, so it's always about following the direction of the current. How does current move through the circuit? And then our first question, it says that we should calculate. Okay, so calculate the effective resistance of the circuit. Hope that is clear. So calculate the effective resistance of the circuit. And then the second question says that we should calculate the reading on ammeter A1. And then C says calculate the reading on ammeter V1, V2, as well as V3, right? And now also calculate the reading on ammeter A2 and A3. So let us start there. Let us start by calculating the effective resistance of the circuit. So that is just the total resistance in the circuit. So how do we go about doing that? So we will know that the total resistance in the circuit will actually be given by, so say R total would actually be given by the sum of this resistor here. It's connected in series to the battery as well as to this ammeter, plus the resistance of the parallel connection. Okay, so we have what the resistance here is just was that the value for that. I actually didn't write the values, so that was a mistake. Let me write them. So the value for this resistor is 3 ohms, the value for this resistor is 2 ohms, and this one is 4 ohms. Okay, so just add that information on your drawing. Okay, so we know what R1 is, 3 ohms. RP, we have to find it because it's for this parallel connection. So, okay, let me put this. I hope they both appear in the short. Okay, so to find RP, we use 1 over RP equals to 1 over R2 plus 1 over R3. And it's just a matter of 1 plus over 2 plus 1 over 4, which is equals to 3 over 4. And then we know 1 over RP is going to be 3 over 4. We just invert this thing to find that RP is actually 4 over 3, which is equals to 1 comma 33 ohm. Okay, cool. Okay, now we have to now substitute RP into our original equation to find the total or the effective resistance. So we said R1, the value of it is 3 plus 1,33, which is the value for our resistors that are connected in parallel. This is going to give us a value of 4,33 ohms. So we have found the answer. Okay, so now moving on. Oh my god. Okay, that was just my alarm. So now moving on to question 2. It says now we should calculate the value, the reading on ammeter A1. So we want the reading on this ammeter. Remember, there's your current, the total current. This has zero resistance, so the total current supplied by the battery will actually flow through this ammeter A1 as well as through this resistor here. So let's find it. So if we do that, so to find, meaning what we're actually looking for is the total current. So we know that IT will actually be equals to I1. So the current that is flow, the total current will actually be the same current that flows through here that we will call I1. So we're looking for I1. Okay, so how do we find it? To find IT, we can just simply use Ohm's law and say that's not R there, it's V, and say let us see, that will be V to find IT. So we say it's equals to V external, because that is the total what is it, the English is going away. So that is the total potential difference supplied by this battery, the extent to the external circuit, divided by RT. We know what RT is. We already know the value for this. So we know it's given to us V external is equals to 12 volts divided by RT. We found that in the previous equation, the previous question, and it is 4,33. And if you put this in your calculator, I believe that you should come to a value of about 2,769 amperes. So that's the value that you should come to. But now we found IT. We're not really looking for IT. We're looking for the current through this ammeter A1, right? So we know that because they are in series with each other, IT will actually be equals to I1, which is equals to 2,769 amperes. Okay, so I hope that makes some sense. So let's write that. So that will be 2,769 ampere. Okay, so that is the total current. So the second question is saying to us, calculate the reading on voltmeter V2, on voltmeter V1, V2, as well as V3. So we want the reading here, here, as well as here. So let us start with V1. So V1, remember we always start from Ohm's law, which says R, however you want to write it. So I1 would actually be equals to, so we're looking for V1. Okay, sorry about that, apologies. So I1 will actually be equals to V1 over R1. So do we know, so we're looking for V1. So it's just a matter of rearranging to find that V1 equals to I1 multiplied by R1. So we know what I1 is because we just found it to be 2,769 in the previous equation. We know the value of R1 is 3 ohms. So we have 2,769 multiplied by 3. And if you do this calculation, I think you're gonna come to a value of about 8,307 volts. So that is the reading that this voltmeter here will actually read on your resistor. Okay, and then our second question is actually asking us to calculate the reading on voltmeter V3 as well as V2. So the important thing to know that here these two resistors are in parallel. And remember, the thing about parallel resistors is that the potential difference through them is the same. So VP, so the potential difference for this parallel connection VP will be the same as the potential difference at voltmeter V2 as well as the potential difference at voltmeter voltmeter V3. But then how do we then find VP? To find VP, we actually have to now go back and say, okay, we found V external will actually be made up of V1 plus VP. It's almost like we reduced these two resistors into one resistor, and we call that resistor VP. So they will sort of be, R1 would be in series with RP. So meaning they will split the voltage, the total voltage, which was given to us as 12V. So we know what V external is 12. V1, we just found it to be 8,307 plus Vp. So we can find the potential difference for this parallel connection by simply taking this to the other side. If we do that, it's 12 minus 8,307, which is equals to Vp. And we know that this Vp, the potential difference for the parallel connection will be the same for V2 as well as for V3. So we have essentially found it to be 8,307 volts. So I hope you can follow the logic around here. So now that we have found what Vp is, we can now actually proceed by finding the reading on this ammeter here as well as the reading on this ammeter over here. So how do we do that? Let me just wipe this. So remember, this because these two resistors are now into, there are two separate branches. They are connected now in parallel, meaning their current dividers, meaning that that IT that is coming is going to be split between the current here at this branch, we called it I2, as well as the current on this branch, we call it I3. We know what IT, how much IT is, but we don't know what I2 as well as I3 are. So let us see if we can actually do a quick calculation to determine the reading here at A2 as well as at ammeter A2 as well as the reading at ammeter A3. Okay, to do that, we will say, okay, we found Vp, which is equals to V2, which is equals to V3 to be 3,693 volts. So meaning if I want I2, which is the reading on this ammeter here, I can just simply say it's going to be V2 divided by R2. So V2 is 3,693 volts divided by, I don't need to write it, the number, the value there is 2. And then I3 as well, because it will be the reading on this ammeter there, it's V3 divided by R3, which is going to give us 3,693 divided by 4. So you can just put this in your calculator. Here you'll come to a value of about 1,85 amperes, and here you come to a value of 0,92 amperes. So, and then if you actually check, you find that 1.85 plus 0,92 will actually give us back, take us back to this value of 2,769, right? So I'm hoping that you were able to follow this logic and are able to actually solve these types of equation, because in the next lesson we're going to talk about another important thing, which is internal resistance of a battery.